joined here with Mars 2020 engineer Farah Olive, and welcome. It's a beautiful day to be doing some testing.
Yeah, it's a great day. Not too much sun, but no rain today.
That is good. The rain is coming tomorrow, and that's going to make for a very muddy mess for Scarecrow, that's for sure. So tell me a little bit about the process and what we're going to be testing out today.
Okay, so behind you what you have, as we mentioned, is our testing rover. And today we're testing some of our software capabilities on the rover. So you're here in the Mars yard, which it's sort of like Mars on Earth, right? We have the grayish, orangish colors of Mars and a set of rocks behind you. And what the rover is doing is we're commanding it to drive to certain areas within the yard, and it's figuring out by itself where to go. And we're actually preparing here for tests that we'll do on the real rover.
That's right. And so why is it so important to test Scarecrow here before we test in the clean room?
Well, so Scarecrow here is fairly easy to repair. We have spare parts. It's a pared down version of the real rover. So it's okay to be a little bit more adventurous with it, to spend the time doing our testing, finding the errors in the software, understanding how it all works. Once you get on the real rover, the thing that's going to Mars, we want to be really careful about that, right? We do not want to crash into anything. We want to be very, very gentle with it. And also, there's other customers that use the real rover. By customers, I mean other engineers. So we have all the instrument scientists, all the other people on our team that we have to work with. They all want time on the real rover. So by the time we get to use it, we're usually using it in a very constrained period of time. So we have to make sure that we're ready to use it and make the best of our time.
That's efficiency is always the key, and we lovingly call it Scarecrow, but as we say, it has visited the wizard now and gotten a brain. So tell me a little bit about what are some of the mission goals for 2020, and also about the caching samples that are going to be used while it goes on the red planet.
Yeah, so one of the really cool things that Mars 2020 is doing is it's taking an updated robotic arm, and what we'll be doing is taking samples on the surface of Mars. So Mars 2020 is going to be moving to different areas on Mars as varied as possible, so we can get a very varied set of samples, and that can tell us different things about the Martian history, but also we're looking for signs of ancient life, right? Sign of extant life that might have been on Mars in the past. So we're collecting these samples, and we have a chemistry kit that's going to help us analyze them, but we're also putting them into a caching system with the hope that one day maybe we might be able to bring them back to Earth. But Mars 2020 also has other instruments. We have a weather station on Mars, Mars 2020, which is a set of wind sensors and temperature sensors that gives us the weather on Mars. But why is that important? Well, if we send astronauts there, we want to understand what the weather on Mars looks like, how it varies with different regions. We actually already have a couple of weather sensors on Mars, so that's going to be an extra one. But one of the coolest instruments that I think is really awesome is MOXIE. And MOXIE is a technology demonstration that's going to extract oxygen from the Martian atmosphere. And the goal there is we're doing that on a small scale because one day if we send astronauts to Mars, maybe through the Artemis program, we might want to have oxygen for them. And so we're demonstrating our ability to extract that oxygen and maybe produce it for astronauts in the future.
Which is really, really incredible. And the future is always how we look beyond. So what can we do to improve? Of course, Curiosity as well as InSight all had weather stations on it as well, but it's been an upgrade. There's a lot of upgrades from the past landers and rovers. So let's talk a little bit about the wheels, which we have here behind us. So this is the wheel from Curiosity.
This is a replica of one of the wheels from Curiosity, and one of the challenges we've had with the Curiosity wheels is that they ended up getting quite a bit of damage. So one of the things about Mars is we always think we know a lot about it, but we're always surprised. And the surface of Mars turned out to be a little bit different from what we expected it to be. And we saw quite a bit of damage on the wheels. And you know, when you're on Mars and you bring your car to Mars, you can't call AAA to get a wheel change. There is no pit stop. So you're stuck with the wheels you have. And Curiosity has been doing really great for a very long time, but we were looking for upgrades on our wheels for 2020. So one of the things we actually did out here in the Mars yard is that we tested different wheel designs. So we set out a set of rocks out there and took this wheel and put it through a lifetime testing to show the damage and replicate the damage we had. And then we tested out different designs. And the winning design was this one. So this is the new Mars 2020 wheels. So they're a little bit different. They have a curvy sort of signature, tread that reduces the stress on the wheels. And so these ones have gone through the lifetime testing and they've done a lot better. So we haven't seen any damage on those yet. So the hope is that we'll have some nice shiny wheels on Mars that are going to last quite a long time.
That's fantastic. And that's why we have a lot of rocks out here, which actually is just about to go over our rock right now. But that's why you've put a lot of rocks out here too. And another difference that we've spoken about is the fact that it's actually going to be able to take pictures while it's driving, unlike Curiosity. So talk to me a little bit about that.
Yeah, so our Scarecrow, as you mentioned, got a brain. So we have a second computer on Mars 2020. So with Curiosity, when it's driving on Mars, it can do automated driving, but when it's driving on Mars, it doesn't have enough computing power to both drive and take images at the same time. So it has to drive a little bit, take an image, drive a little bit. Now, why do we take images while we're driving? Well, so when you're here on Earth and you're trying to go somewhere in your car, you have Google Maps, right? It's preloaded. If you have no signal, you preload it ahead of time. It defines the path for you ahead of time, and you follow that. On Mars, we don't have GPS. We don't have Google Maps yet on Mars. So what the rover does is it has to build its own map. And it does that by taking images every meter and building its map. So if you can imagine, if you were moving along and every meter you stopped, updated your map and then figured out the directions for that 1 meter and so on, that's actually quite a bit of computing power. Mm-hmm. So Curiosity can't do that while it's driving, but Mars 2020 can, and it's actually what the rover is doing right now, believe it or not. So what it's doing is it's trying to get to the other corner of the yard right now, but there's all these rocks on purpose there that are obstacles. Some rocks it can drive over, some rocks it has to drive around, and it's possible actually, depending on the system that we've set up, that it might not have a solution. So what it's doing is it's moving a little bit and taking images every meter or so and then trying to figure out a solution. But it can do that while it's driving, so that's a lot more efficient than having to stop and think every time.
Now, Mars 2020 is not going to win a Ferrari race, that's for sure, but it is faster than Curiosity.
Yeah, it's about 5 times faster than Curiosity, and that's really important for us for our science goals for Mars 2020, because we want to get really varied samples, so we have to cover a lot of distance. We have to cover more mileage than Curiosity did to get to different environments and get those samples. So this was really science driven. We needed the capability. So the scientists were like, "How fast can you go?" And that's what the mobility team went and worked on, was to figure out how to get around faster.
There we go. And we've actually got 2 questions from Instagram on social media right now. So Jairi, what are the viewers saying out there?
So Lana 8 is wondering, do all the details of it have a weight limitation? So I think she's asking, do we have weight limitations for the rover?
We do, absolutely. So Mars 2020 is a little bit heavier than Curiosity, but we were defined with it. We had to stay within a weight envelope. There's 2 reasons for that. 2 main reasons for that. One is our launch vehicle, so there's only so big a rocket we can get. So the rocket has to have enough fuel to get us to Mars, and that is proportional, so it's related to the amount of mass that you're bringing. So there's a maximum weight that you can bring. But the other big one is our landing system. So we're using the same sky crane as Curiosity did and a big parachute. And so again, your parachute, the area of your parachute tells you how much you can slow down depending on the speed you're coming in at. So there's a maximum weight there, because if we were too heavy, we wouldn't be able to land our system with our current landing system.
And we've done it successfully now twice.
Well, with the parachute and the sky crane, we've done it once.
Right.
That was Curiosity, and this will be the second time, so knock on wood.
Yes. All right, and our second question, Jairi,
comes from Greg Waldock. Can the rovers fight each other for territory?
I wish. On Mars, we're actually going to be in really different areas, so we will not be anywhere close to each other. But one of the things that we're actually doing up here right now, you can maybe see in the background this sort of construction going on, is because there is a Curiosity has its own rover. It's called Maggie. That's sort of an Earth version of Curiosity. and we're actually building up a full version of the Mars 2020 rover that's going to go back there. So we're literally building a 2-car garage out there, which is going to be really neat. And I'm actually personally really looking forward to getting the 2 rovers out here. So maybe we'll get them to race at least. That would be pretty cool.
And what's really neat is you've got so many different terrains here on the Mars yard. And if you look over at those hills, those are the terrains that you've actually tested to go downhill or uphill.
Yes, so there are different slopes there. Some we can go up and some we can't. And we do a lot of slope testing all over the yard. And actually one of the things we have tested is we've given Scarecrow targets on those hills, and it knows which hills it's able to go up and which it's not. And we've also got different materials because the different properties have different amounts of friction. So on some of them you might slip, and some of them you might be able to go straight up the hill.
Right. Now going back to navigation tools, you're an engineer on Mars 2020, and you specialize in basically getting Mars 2020 where it needs to be on the red planet. How does she do that?
Yeah, my job is to make sure it knows where it is, which, considering how often I get lost, it's pretty funny. So the rover actually has multiple ways of knowing where it's going. So one of the things it's doing right now, as I mentioned, is it's taking images. So as it goes along, it builds a map, and it knows where it is within that map. The fancy word for that is visual odometry, or VO, and that's how it knows where it is within that map. Now, that's helpful, but there are other ways that it knows where it is. So one is it has a gyro compass and accelerometers. So on your phone, you have accelerometers. If you've ever had to, for example, use a map system and it happens to know which way you're pointing, well, how does it know that? It's because it has those gyros on board. If you've ever used a compass on your phone, that's the same system it uses. So literally the rover has a compass that does not use a magnetic field. It uses just the gyros and the accelerometers to figure out where it's pointed. But then, the same way as explorers do, we also use stars to navigate, right? Explorers here on Mars do, so on Earth. So on Mars, we use the biggest star of them all. We use the sun. And so the rover actually will look at the sun, and if it knows what time it is, we've all learned this in Scouts or early navigation, right? You know what time it is, you know where the sun is, you know where you're pointed. So that's also one of the ways that it knows where it's going.
So it is definitely smart. So
Yes,
it knows where it wants to go as well. We do have another question here on social media, Jairi.
Okay, so Cadet Atharva 7420 asks, how is exception handling done in emergencies? So I think this person's asking, what happens if you have a problem? How do you handle that in an emergency?
So the system, so that's one of the things that we actually test, right? And we test this over and over again, is we have something called a fault protection system. So we, as engineers, what we do is we figure out all sorts of faults that can happen, and then we test and protect against them. So the system has different reaction depending on how bad the emergency is. So there's easy things like in the yard, for example, if it can't find a solution of where to go, well, it'll just stop and call home. If all of a sudden it's getting a weird reading on one of its temperature sensors, it might shut down that part of the system. There are emergencies through which we might reset the computer. So a little bit like what you would do on Earth, if you have, say, a problem with your computer and one app is frozen, well, you might just close that app. If the whole computer is frozen, you reset the whole thing. And if things are really bad, we have what we call safe mode. So if the rover doesn't quite know what's happening and it can't self-diagnose, it will shut down and go down to a low power mode, and then it calls home. We're sort of IT when it comes down to operations, right? So it calls to IT and it's like, hey, here's some data, something's up. Can you help me?
A very souped up version of ET phone home.
Yeah.
Yes. So we are also looking at it, doing some testing on different terrain here as well. Now, how will all of the testing here on the Mars yard help when you guys finally do the first drive test in the clean room?
In a couple of weeks, yeah.
Yes.
So one of the things that we're doing here is we're testing sort of the edges of flight software, all of the bugs that we've had. We're testing maybe some things that might be more challenging. Again, as I mentioned earlier, we want to do them here, work out the kinks, figure it out. This is kind of our dress rehearsal.
It's trying to get on top of that rock right there.
All right.
So like you said, it's a dress rehearsal. It's basically trying to figure out its functionality.
What we'll be doing in the clean room will obviously be a lot simpler. We're not going to have rocks in the clean room. We're sort of doing a straight drive and turning around, but we're using the full system too. So here what we really want to do is make sure we understand all the systems and make sure that our procedure for the clean room is going to be great, and so that by the time we get there, we're all set and good to go.
And those wheels look like they're handling those jagged rocks very nicely.
Absolutely, yeah.
And we are going to be looking at some pretty rough terrain. Tell us a little bit about the difference between the terrain on Mars versus the terrain on Earth.
So one of the interesting challenges, right, one of the reasons Scarecrow looks like this is that gravity on Mars is actually different, right? So we're at about a third of the Earth gravity. So when we use the full blown up Mars rover, it's actually the sagging and the friction is different than what we get on Mars. So Scarecrow is actually adapted to be a lower mass so that it's the same weight. So weight is mass and gravity together. So it basically weighs the same as approximately as Mars 2020 will on Mars. And that's really important when you're doing testing because things like friction are related to that.
All right, that's very interesting. We have another question coming at us from Instagram, Jairi.
Akbari Matul asks, does it have a suspension system? And how does it work?
So we have our rocker boggy system there, which is the same thing that we've used on all of our rovers. So we have a 6-wheel system, and you might have seen it drive over time. And what it's able to do is all the wheels are, so you might be able to see it. All the wheels can individually actuate, which is not like your normal car, right? And you'll see, for example, right now the back wheel is going to pop up without the other wheels coming up. So that's the advantage of that system. It actually started up with Pathfinder. It had this system, and all the rovers on Mars, I've had that particular system. It works very well. Still not going to be a smooth ride if you were to ride on one of these rovers, right? You're not. It's quite rough, but it's great for the application that we have.
And we have another question.
Okay, and this is a good one to kind of look forward to something. Janish Ramesh asks, what's the name of this Mars rover?
So we just had a competition. That's actually one of my favorite things is that it was actually middle school students that get to name the student and high school students. So they're, I think, a lot more imaginative than I would be. So for Curiosity, that was actually a student back in the early 2010s that named that rover. So we opened up a competition that just closed a few weeks ago, and there was also an open call for judges. I think the judges have been selected, and they're starting to review those names, and we're hoping sometime early next year that we'll get a name. So I heard there was a lot of submissions, so I hope there's some good ones in there because Mars 2020 is not, it's kind of a handful, right? It's a mouthful, and we want something a little bit more awe-inspiring and imaginative for our rover.
Yes, and especially inspiring the next generation. I mean, that's what we're all here to do, and the Mars generation are the people that are actually going to be able to go up there and explore the red planet.
Absolutely.
Along with the rovers that are paving their way, that's for sure. So can't wait. February, we should know the name of Mars 2020, so we'll keep you posted on that. But remember, you can go on @nasajpl on all our social platforms to not only get the very latest that's happening with Mars 2020, but all the amazing, incredible things that we're doing here at JPL and at NASA. Have an awesome day, and goodbye from the Mars Yard.